Okay, section 3.3 is about inverse functions, and example 1 is asking us to graph y equals x squared, then find the inverse. Well, we just did a whole deal on graphing or families of graphs. We know that this is a parabola, but when in doubt, when you don't know on a graphic, plug in a value for x, get a y. If I plug in 1 for x, I get 1 for y, so I have an ordered pair 1, 1. If I plug in 2 for x, I get an ordered pair. I get 2 squared is 4, so 2, 4. All right, and again, if I plug in 3, I get 9, which is way up there. If I plug in negative 1, I get positive 1 when I square it. When I plug in 0, 0 squared is 0. Negative 2 squared is a positive 4, and so forth. Remember, it was a parabola that looks like this, right? Okay, so it says graph y equal to x squared, then find its inverse. Well, we know the inverse is when you just switch the x's and the y's. So this ordered pair is 1, 1, so it's 1, 1, sorry. So its inverse will have a graph at 1, 1. This ordered pair is 2, 4, so its inverse point will be switched around 4, 2. So over 1, 2, 3, 4, up 1, 2. 0, 0, if we switch those two ordered pairs around, we still have 0, 0. Negative 1, negative 1, 1. And if it's the inverse, we just switch the x's and the y's. So we get 1, negative 1. Negative 2, 4. We switch the x's and y's, we get negative 2 over 4. So the inverse graph of x squared is a graph like this. And in fact, if you think about it, if we were to find the inverse of this graph, we switch the x's and y's and we solve for x again, right? So it would be x equals y squared. When I solve, you take the square root of, I got to solve for y again in order to solve for the inverse. So you take the square root, y equals the square root of x. And we know when we take the square root, it's plus or minus, right? If you were to type in the square root of x into your calculator, you'd just get this top half of the graph, right? But we know it's both the positive side and the minus sign when we take the square root, so that's why it's a graph that looks like this. All right. Okay. So this is actually the graph of y equals plus or minus the square root of x. So we'll graph in the red, and that's its inverse. We just switch the x's and y's. All right. And to further prove that point here, we're going to go ahead and look at finding the inverse of f of x equal to x squared minus 4, and then graphing both the function and its inverse. Well, we know in order to find the inverse, we just switch the x's and y's. So we're going to say x equals y squared minus 4, and solve for y again. So x plus 4 equals y squared. Y equals the square plus or minus the square root of x plus 4. All right. So this regular function, we know that on the outside of the parentheses, when it wasn't included inside the parentheses, it moved it up or down. So when it's outside the parentheses, we're going to move it down 4 is going to be your vertex. All right. And then it's in the shape of a parabola. It's not going to be bigger or wider or narrower because we're not multiplying it by anything out in front here. All right. It's just moved down 2 and moved down 4 and it's a parabola, just like we saw it. And actually, parabolas have a pattern: up 1 over 1, up 4 over 2, so up 1, 2, 3, 4 over 1, 2, over 1, 2, and so forth. And that's just a parabola. And if we wanted to graph this other guy, we know what the square root graph looks like. And we know if it's inside the parentheses, so this would be the same thing. I believe we graph the function y equal to x plus 4 to the 1/2 power, which is also the same thing as the square root. All right, and again, it would be plus or minus. Okay, so we know if it's inside the parentheses, it's moving it left or right, and it moves it opposite of that sign. So we're going to move this thing to the left 4, and then again, it would go maybe in a parabola just like this, over 1, 2, 3, 4, up 1, 2, and then down 1, 2. And if you think about it, if you look at these ordered pairs, this ordered pair is 0, negative 4. So its new ordered pair is going to be negative 4, 0, which is over here. This ordered pair is negative 1, negative 3. So its new ordered pair is going to be negative 3, negative 1, which is here. All right. So that's going to be its inverse of that graph. So you have two options. You can graph the regular one and then find its inverse, or you can find its inverse and graph both of them if you feel comfortable with your parent graphing. All right, your parent graphs. the last thing to talk about here is called the horizontal line test. It says we remember the vertical line test. The vertical line test told us whether or not something was a function. So in fact, if I were to draw a graph back up here and draw that square root function that was something like that, right? And if I was going to ask you if that was a function or not, you guys would all tell me no because it doesn't pass the vertical line test. All right, it doesn't pass the vertical line. It passes through that graph twice. All right, well, the horizontal line test is similar to that. Now, the horizontal test is a test to tell whether the inverse of a function is also a function. So if I draw a function on here, any old function, if I draw a straight line, if I draw this, if this passes its the horizontal line test, that means that its inverse is also a function. So that guy's inverse is a function. All right. If I were to draw, say, like the parabola that we just had there up above. All right, we graphed this earlier. This is the example beforehand. If I were to draw a horizontal line through this function, it passes through it twice. Therefore, its inverse is not a function. You would all agree that this graph is a function because it passes the vertical line test. But its inverse is not a function, and that makes sense because we've already graphed this guy's inverse, and we knew it looked exactly like this, right? It looked like that. Well, if you're looking at that inverse, is that thing a function? Well, no, because it does not pass the vertical line test. So I hope that helps, and that's all we have to cover in this section for right now, and we'll see you in class.